This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Hello listeners, Markus here. I just wanted to tell you about 2 things before we actually get started with today's content. First, yesterday we published an interesting episode on Omega Tau, my other podcast that deals with non-software topics. This time it actually deals almost with a software topic. We talk about simulation, numerical simulation in cosmology. Obviously, the episode is mostly about the cosmology and the physics, but we talk quite a bit about the computing hardware and the software. So you might want to check out Omega Tau at omegataupodcast.net. The other thing I wanted to talk to you about is our new team member, Robert Bloomin. He already did an episode recently and we completely forgot to introduce him. So that's what we'll do now. Hi, Robert.
Hello, Marcus.
Welcome to the team.
Thank you very much. It's great to be here.
So where do you live? What do you do?
I live in San Francisco, United States. I've been active in professional software development for over 20 years. I'm an independent enterprise software consultant focusing on financial services. Currently, I'm working with a startup that's doing something interesting in the area of decision science and risk management.
So then, do you have any special focus for your SE Radio episodes?
For my interviews, I plan to focus on web application development, mostly on server technologies, things like emerging databases, large system issues, and frameworks.
Okay, great. So I guess the listeners and of course also the rest of the team and myself, we're looking forward to many great episodes about some of these topics.
Thank you very much. It's great to be part of the team.
Well, thanks for joining. Okay, so that's it with my announcements. Let's get back to today's content. And this is actually an episode from Robert about AOP. Have fun.
This is Robert Bloomin. I'm here at QCon San Francisco 2009 with Ramnivas Laddad. Ramnivas is one of the leading thinkers and writers in the AOP and Aspectj field. Today we'll be discussing his book, Aspectj in Action, 2nd edition, Enterprise AOP with Spring Applications. Ramnivas, welcome to Software Engineering Radio.
Yeah, thanks, Robert. Nice to be here.
It's great to have you. Tell the listeners about your background.
I work at Spring Source, which is recently acquired by VMware. I work on various projects related to aspect-oriented programming. I'm also a Spring Framework committer, mainly work in the area of aspect-oriented programming. So at Spring Source, I essentially have 2 roles. One is to really work with several internal products, as well as contribute to the Spring Framework, and also help customers be successful with all of the Spring and related technologies.
You are one of the first people to write about Aspectj. You've been involved with it for a while. How did you get involved with Aspectj?
Pretty much by accident in a way. So at some point, I keep recalling, what was my first interaction with Aspectj. And I do remember just somehow going to the page about Aspectj. And that time Aspectj was 0.3 version or some very, very low version. And I looked at it and I was like, that's something interesting. Because this problem was nagging me and it seemed like, wow, that's the right way to do it. And at that point, I said, okay, interesting. I kept in my mind that someday I'm going to look at it. I really didn't do much with it at that point. And then I started to look at about 0.8 version of Aspectj. And this was maybe around 2000. And I started to look at it and I started to use it initially only in development aspects. So I wouldn't put it in production, but I would use it to improve my productivity, find out some of the hard bugs, thread safety related bugs. And then when version 1.0 came, I started to actually be very serious with production usage, wrote a bunch of articles for Java World. And then I wrote the first edition of Aspectj in Action, which really was almost like a reaction to a typical claim about Aspectj. That's you can use Aspectj for logging and tracing, and that's about it. And I knew that is not right, that is not true. But rather than just making a counterpoint, I just made a counterpoint with writing a 500 pages book. And ever since I've been using Aspectj in various things, with Spring and non-Spring applications. So it's been pretty associated for a very long time with AOP and Aspectj.
So Software Engineering Radio has already done some episodes on AOP. I think the listeners are familiar with it, but I'd like to do a brief thumbnail of what is AOP, then we'll proceed and talk about your book. Can you give us a short description of what is AOP?
So there are certain class of functionality where object-oriented programming simply cannot do the right job. For example, transaction management, security, logging, tracing, exception handling. So what we need is actually a method or a functionality, a programming style that can help us isolate these kind of concerns, what are known as a cross-cutting concerns, from your mainline business logic. So the idea is then you can focus on one thing at a time. I mean, it is typically said that a typical human cannot handle more than 7 concerns at a time, 7 independent concerns at a time. Now, as far as I'm concerned, it's more like a 2 or 3. I don't think I can handle more than 2 or 3 concerns at a time. And that's kind of good because, I mean, that's really the reality. I mean, human, this is just the way it is. So what we need is we need a way to separate them out so that I can focus on transaction management once, then I can go and focus on my business logic, then I can move to security and so on. So basically, aspect-oriented programming is a way to really help you realize this possibility.
So aspect-oriented programming is a programming language technology that enables you to modularize concerns.
Concerns that are known as cross-cutting concerns, because object-oriented programming is already good at certain kind of other concerns. It's just the cross-cutting concerns where it doesn't have adequate answer.
Okay, so there is some terminology that we'll be using and like you to define for the listeners. Point cut.
Yeah, so when we want to implement, let's say, transaction management, we want to figure out two things. One is, where do I want to apply my transaction? Where do I begin? Where do I end? That's one part of it. And the second part is, what do I mean by transaction management? When I say transaction start, what code do I want to run? So the first part, that is of selecting what point you want to apply your transactions, is done through the construct called point cut. You can think of point cut like a SQL over your program space. So you can say, okay, in SQL, what do you say? You say, here are tables, give me, let's say, accounts where the balance is greater than 25. Whereas point cut says things like, give me methods where the type is account and the method starts with set, or throw certain kind of exception. So essentially you're doing a query over your program space, and you can use this point cut and then apply your cross-cutting logic.
The next term is advice.
Advice is that cross-cutting logic. So you basically can say, before the method that I selected using this point cut, transaction management point cut, applies, start your transaction. After you're done with that method, depending on whether exception was thrown or not, you either commit or roll back. So the advice is essentially the code that will run in addition to or instead of the original logic.
Okay, so an aspect combines a point cut with some advice, is that right?
Exactly. It also has some additional constructs, but basically advice and point cut are the two main constituent of an aspect.
And talk a little bit about weaving.
So now once you express this aspect, and I will continue with the same example of transaction management. So you wrote a point cut that says these are the methods that needs to be applied with transaction management, and this is the transaction management logic. Now you need to basically have your classes and aspects combine in such a way that you get the end effect that you would expect that transaction to be called certain methods, points, ends at certain points. So this mechanism by which you apply your aspects to your code is called weaving.
So you've given us a brief introduction to AOP, and Aspectj is obviously some kind of Java tool for programming AOP. Tell us, what is Aspectj?
So Aspectj is, you can imagine Aspectj to be extension to Java, just like C++ was extension to C. So what C++ did to C was added some new keywords, added some semantic, and and also provided a compiler that could understand those syntax. Aspectj does exactly the same thing with Java. It adds new keywords and that associates new semantics, and it gives you a compiler-like entity, which is also sometimes called Weaver, which really understands that syntax and then produces you bytecode. That bytecode you can run it on any standard VM.
So Aspectj allows user to define point cuts, advice, and weave them together in a Java environment.
Exactly. It also provides you tools, mainly AJDT, Aspectj development tool, which is really extension to JDT, which is in Eclipse. So what it allows you to do, it allows you to visualize what your point cut is selecting, what's your effect of your advice, in a comfort of your IDE. So that gives a very seamless experience, very Java-like experience, but extends it to aspect-oriented concepts.
So Aspectj provides two different programming models. The one you've been describing is the language extension model with the new keywords. There's also an annotation-based model. How does that work?
So this is a new trend since Java 5 came about, is you can use annotation to associate some additional meaning to your programming elements. And for example, you can say this method is transactional using by add transaction annotation. What Aspectj does is it associates some annotations to methods, classes. So for example, instead of using a keyword, use annotation. Advantage of this style is this code is really plain Java from Java compiler's perspective. So you can just use Java compiler and compile your aspects, and you can postpone the use of Weaver a bit later. And we'll talk about those as we kind of go through the interview process. So what it allowed you to do, it more importantly, is it allowed you to be even more comfortable with that this is more even closer to Java. And it also allowed you to use it from within Spring AOP environment, which does not use a bytecode viewer, but uses a proxy-based mechanism. So it sort of made adopting Aspectj even simpler.
Would it be correct that if you go the annotation-based model, some types of syntax errors that would be detected in the language model will not be found until a later stage in the test cycle?
To some extent, that is true. It really depends on your tool environment. So if you use, for example, HADT will flag you programming error because it does understand the annotations and their semantic meaning. So it will flag those errors. But if you use some other tools, then yes, it will be postponed until the time when rubber meets the road, so to see, like when aspects is about to be woven into Java classes or aspect is loaded and interpreted, that time it might come back with an error.
What are the tools that Aspectj offers a programmer for defining point cuts?
So point cut is a language. It's very similar to the way to approach point cut is like a SQL. So essentially you write your point cut just the way you would write a SQL. So essentially tools almost harm rather than help. So Aspectj remains pretty much take hands-off approach there. So you write point cut and it offers you cross-cutting references view, which will allow you to understand the interaction between your Java code and aspect. And based on that information, you can refine your point cut to match your expectations.
Okay, I think I asked the wrong question, so I'm going to ask this question again. What types of programming constructs can the programmer pick out using the point cut model?
That's a very good question. When you select programming elements, you really want to use the characteristics associated with the programming elements. So the most simple is just the method name or the type name. So you can say I want to select all methods in account type, or you can say I want to select all methods in account type that return certain type of value. You can also select I want to select all methods in account subtype. Very interestingly, Java 5 that also offered us the annotation-based way to express aspect also offers an interesting way to select join points. By the way, I didn't explain the join point concept. The things that point cut selects are known as join points. There's a bit more to it, but roughly speaking, essentially, it's the entities that get selected.
So point cut is defining a specification of what you want, and then the join point is like the result set in a SQL query?
Pretty much, pretty close. Only difference is join points are considered dynamic, so they occur during execution of the system, but they have some static what we call shadow. So as in we know the certain method will be selected, but the join point will come about during execution. It gets best used to it, this terminology, but it eventually you will get it. Usually, most people get it in about half a day. So going back to the concept of selection mechanism, Java 5 offers annotations, and point cut can use those annotations. So let's say suppose you want to select transactional methods. It's very difficult to come with a naming convention or a type naming to collect all the points that should be applied with transaction management logic. So instead, what you do is you ask Java classes to really have those methods be annotated with, let's say, a transaction annotation, or the class itself be applied with a transaction annotation. And point cut can say all methods that carry this annotation, or all methods in a type that carry this annotation. So essentially now you have a little bit collaboration from classes, and Aspect can use that collaboration.
If I was writing a purely technical aspect like a logger, I might be able to specify where I want it to apply based on being in certain packages, certain classes. But when you're talking about transaction, it's really a business concept, and how's the point cut going to be able to pick that out unless you give it a little help?
Exactly. And that's really kind of was a sore point. I mean, one of the reasons most people were finding Aspectj difficult is really the art involved in Aspectj or AOP in general is really defining that point cut. And as you mentioned, for logging, tracing, exception handling, you can just simply go with a very simple package structure or type naming convention, and you would do a reasonably good job.
After you become familiar with this tool and you're using it in a project, do you start designing your project for ease of applying point cuts?
To some extent, yes. So some aspects, if you know that you are going to use aspects, you would not worry about those cross-cutting concerns right away. So instead you would think, how do I indicate that I want this code to be secure? How do I indicate that I want this code to be audited? Or how do I want this code to be transaction managed? And then aspects will simply leverage it. So essentially, the way to look at this annotation in this context is annotations are kind of interfaces, a different kind of interfaces. So your mainline business interface is for other classes to use, but the annotation-based interface is for your aspects to use. So the way, in fact, the way I like to describe in a very general sense is it's like now you have multidimensional interfaces.
When you're writing Aspect, the Aspectj packages expose some reflection APIs that you can use. What are the kind of things you can access from the reflection API?
So when you reach a join advice, at that point you want to know more about the join point you are currently working with. So you want to know, for example, what is the type in which that method is defined, or what is the method name, or what are the arguments to the method. All that information you can get through the reflection capability. So essentially it gives you access to a few variables. Just like this variable, there is something called this join point static part, and so on. And those variables, then you can go inside that those you can access their properties and get refined.
So when you go inside that, can you then find the data is defined by the java.lang.reflect API?
You can get that as well. So you can get, for example, the method object, but more typical usage is to really know about the object at which the method is being invoked, or the arguments to the method, or the method name, because then, for example, then you can do tracing, or you can do auditing, or for, let's say, transaction management, you can get the annotation itself. So you can say, is it a read-only annotation, what kind of propagation, and so on.
So suppose you have multiple aspects that might apply. You could have a transaction on some methods, and you may be logging and tracing more everywhere. So you have multiple aspects that all hit the same join point. Is there a precedence logic to the way that they fire?
Absolutely. So if you don't provide any special mechanism, any special construct, Aspectj is going to apply in some arbitrary fashion. But if you do want, let's say, transaction to occur before security, then you declare your transaction management aspect to have higher precedence. There's a construct for that than security. And then transaction management code will have higher precedence. So the before advice will go before the security, and after advice will go after the security. So it's a pretty neat mechanism.
So you can pretty much control it.
You can pretty much control, and it's pretty powerful mechanism. You can have partial ordering. So somewhere you may say transaction management aspect has higher precedence than security, but somewhere else you may say logging has higher precedence than security, and then it will do the ordering between considering all the statements.
Aspectj provides the ability to modify the static structure of your type system. Tell us about that, and why is that considered part of AOP?
That's a good question. So let me explain what that mechanism is. So this mechanism is generally called intertype declaration. So one type, in this case aspect, is declaring some structure for other type, and that structure could be a base class, could be introduce member, so I can introduce new methods into a type. Now why is it in AOP? So taking a step back, this mechanism is actually available in other languages, and essentially under the open classes principle. So you have a class and you can open that class and make some additional modifications, and that's pretty rich mechanism, and that's powerful in a lot of ways. So why is it part of AOP? However, aspects often need classes to really carry some additional structure. So for example, let's say if I have a dirty tracking aspect, I want to declare an object to be dirty or reset it dirtiness. So I don't expect the class itself, the original class, let's say account class, to carry a dirty boolean. Instead, I will have an aspect, a dirty checking aspect, to introduce that field, and then advice is going to modify that field as needed. So essentially, it gives some additional data for.
So it's a way of creating per instant state for an aspect.
Exactly.
Correct?
So that aspect can then collaborate. So aspect can make the object richer and use that richness.
So that way I don't have to decide when I'm writing this or that object that I want this object to support being lockable or cacheable or whatever that might require some additional state. You add that in a separate modularized concern, and that's why you're calling it an aspect.
Precisely.
So let's talk about the weaving model. Aspectj has 3 different weaving models. Can you tell us what they are?
So we talked about you write aspects, you write classes, and then weaving is going to take those together and produce essentially a system that you can deploy it into any VM. Now consider a situation where what if you don't have access to source code? What Aspectj does to kind of get around all this situation is it offers three kinds of models. One is called source code weaving, and source code weaving takes your aspects and classes in source code form and then produces binary. So essentially, it's very similar to how you use Java compiler. The second possibility is built-time binary weaving. So in binary weaving, you take your aspects and or classes in binary form. So you may have some third-party aspects library or a third-party class library, and you can combine these jar files or class files to produce another set of jar files or class files over one jar file. The third possibility is I want to postpone weaving until it is needed, which would be when I'm about to run my application. So it offers a load time weaving. So what it does is it uses Java agent, so JVMTI agent. And that agent essentially detects a class being loaded. And when class gets loaded, it applies aspects at that time and then passes the version class file to the VM. So essentially now you can keep your build environment intact in terms of is not familiar with it, is not doesn't pay attention to it's being aspect oriented, and the viewer comes only during deployment.
So you might choose to use the source weaving if you had all control of all the source, the build time weaving if you had some jar files where you didn't have the source, and then the load time weaving, I'm less clear what's the highest and best use of that.
So source time weaving you will use under two circumstances. One is you have control over source for either classes and or aspects. Binary weaving is if you have, and you can mix and match these things. So you can have source and binary weaving combined. You can have some third-party aspects, some of your own aspects, some third-party jars, some of your own sources. Load time weaving is really interesting if, for example, you want to monitor, let's say, performance of your application. At that time, you just don't want to change your build system. That's what it is. If it is producing a var, so be it. And you just deploy your var and you just want to modify some part of your application server or a launch script that says just weave these performance monitoring aspects. And once you do that, you will get, let's say, some performance metric. In fact, I've been working on a product called Spring Insight, which gives you rich information about running application, and we use load time weaving there. So what we do is we expect users to produce their var as they always have been. No special change. You just deploy it in this special container, if you will, which is really Tomcat with small modifications, and it's going to apply those aspects, produce data, and that data you can view it into dashboard.
So because of who's developing the code and how it gets applied, it may make sense to have the weaving process be as separate as possible from the development.
Right, and obviously there are downsides. I mean, essentially, all of this have the positives and negatives, and you have to kind of look at your situation. So, for example, if you want to use load time weaver, then you are going to take the weaving hit, the performance penalty at load time. So as the classes are being loaded, there will be extra logic being run that will look at your class files, look at your aspects, weave them together, and so on. So if you're okay with that performance penalty, then load time weaving may be appealing because you are getting some additional benefit, as in no modification to build time, and you can take out these aspects anytime. So it's really, there is a whole lot of discussion that goes around this. Is you kind of need to understand the system, and good news is you can mix and match. So you can take bit of performance penalty, but then you can offload it by using binary weaving or source time weaving.
So what are the most obvious use cases for Aspectj in a Java project?
Oh, a lot of them. The way I guess this is a question, I can approach it from the angle of essentially adoption curve, if you will. So for example, if you're starting with Aspectj and you're kind of wondering what is it, and you kind of have some understanding of what this is, but not quite sure, and you want to give it a try. The first kind of aspects you will be like logging and tracing, exception handling, and you can actually get a pretty nifty data by writing an aspect which could be like about maybe 20 lines long. And that time you can even apply load time weaving so that you don't really want to modify your build time. So essentially make some modification to your deployment, and or certain environment is literally like a couple of lines of changes. And you can start to get a feel for what Aspectj can do for you. And that's exactly the approach we are taking with Spring Insight. Then there are other class of aspects, which what I call like a policy enforcement aspects. So their idea is you have some policies in every project. For example, you may want to say, well, I got these layerings. So I have my web layer, my service layer, my data access layer, and there are some contracts. My web layer, I don't want my web layer to go directly access JDBC. I want my web layer to go to the service layer. But who is going to enforce this contract? You can examine code periodically, but that sort of gets boring and you're never sure. You can define aspects that can enforce this contract. There are other kind of very interesting enforcement aspects related to threat safety. So for example, you may declare, okay, this class is thread unsafe. But how do you know that it's being used with that understanding? As in, no two threads are visiting this object at the same time. You can write aspects that can monitor this kind of thing. In fact, the very first CS aspect I used was exactly this class. So I was working on a Spring project, and those who are aware with Spring, there is a very simple thread safety rule, which basically says don't use it from multiple threads. And that's a good reason for it, and it's a good rule. And it's not just Swing, there are other libraries that have the same rule. And we were getting this nasty problem, and this nasty problem would come once in a while, and we would give a demo to customer and it would definitely crash there. And I go back to my desktop and I'm trying it and it never comes up. So what I did is I kind of suspected this is thread safety, because that's usually characteristics, like you never know when the problem is going to come, and if you put a debugger, then the whole characteristics dynamics change and you never see the problem. So I wrote an aspect that was just monitoring, am I violating a rule? Am I calling a Spring component from any thread other than the AWT thread? And as soon as that happened, I logged who is caller, what is the call stack. I could really, in a couple of days of normal development, detect all the issues and fix those.
So getting back to the policy enforcement, this seems to me a real advance, because the way of communicating those things now is the tech lead or the architect will maybe put some best practices up on the wiki, and you hope everyone reads it and remembers to do it. But this allows you to have a automation of these policy
Absolutely.
rules.
I mean, and that's it. I would say that there are tools like find bugs and PMD. You absolutely should use it. I use them all the time. Thing is, those tools and some parts of an Aspectj, they really rely on static structure, and that's okay. But there are dynamic things like thread safety violation. Those are very difficult to detect with static analysis tool. So you can actually have Aspectj extend to even those kind of things.
We'll say you have some very interesting design patterns for using aspects in your book, but people are going to have to read the book to find out all of them, because we don't have time to go through each and every one. So there are a bunch of other aspects. We'll come back to those later. But for now, let's go into Spring AOP. SE Radio has done a couple of shows on Spring, so we're going to assume people can go back in the archives and listen to those. Give us briefly a thumbnail of what dependency injection is, and then we'll talk about how that applies to AOP.
So dependency injection is in a way very simple idea, but with profound impact. So essentially what it says is you want the responsibility of creating object graph in terms of how objects are wired up to some external mechanism. So in this case, a container, a Spring container, for example. And that allows you to essentially have flexibility in terms of what gets wired up with which other object. One important thing you get out of is very simple structure. Second, you get very testable code. So you can, for example, instead of injecting a real repository, you can inject a mock object. And that way you can unit test your service layer. What AOP allows you to do is it augments dependency injection to really make sure that you don't even have to your normal plain old Java object code.
Okay, so how do dependency injection and AOP interact in Spring?
So dependency injection takes care of keeping Java objects simple. So what we call plain old Java objects. So essentially, they won't worry about creating, let's say, a service object will not worry about creating a repository. So it offers simplicity from that point of view. However, by dependency injection itself is not going to take care of things like transaction management and security and exception handling and so on. That's where AOP steps in. So AOP says, all right, you keep your plain old Java objects, keep them plain, but we'll apply these cross-cutting concerns through aspects. And therefore, as a result, dependency injection along with AOP and along with third thing, enterprise service abstraction, keep your code very clean.
How does a developer create an aspect in Spring?
When Spring started, Spring couldn't really use Aspectj because of the bytecode weaving model, and it wasn't well accepted that you can use anything other than Java to develop your systems. So Spring created its own mechanism using proxy-based framework, and that time it also had its own programming model. But since Spring 2.0, that programming model is changed. Now you can use the annotation style aspect that I mentioned earlier with Spring. So what you do is you write your class a class, annotate it with annotations such as at aspect, at point cut, at before, etc. And those aspects, you instantiate a bean corresponding to those aspects. And those aspects Spring will then take care of creating proxies for the other beans and making those proxies call this aspect code appropriately.
So your aspect is a bean in the Spring container, and you could, for example, dependency inject other beans in your container into the aspect.
Absolutely.
Is that right?
So they are first class beans, so you can do whatever you can do with other beans, you can do with aspects as well.
So that is a bit more powerful programming model than purely Aspectj, where you couldn't necessarily inject other pieces of code into an aspect very easily.
With Spring AOP, in fact, with Spring Container, you can actually do that. So you can have your aspects woven using Aspectj bytecode weaving instantiated as Spring Bean. So all you have to do is basically define like a normal bean, except use attribute factory method. And Aspectj has each aspect carries a factory method called aspect of that you use, and that will instantiate a bean. And once that bean is instantiated, you can use normal dependency injection mechanism.
So you can instantiate an Aspectj aspect as a Spring Bean within Spring Container.
Exactly, and that's actually a good pattern. One of the good patterns is dependency mechanism is good no matter whether you use normal plain old Java objects or aspects. So you should use aspects with dependency injection so that your aspect is more testable.
Spring also enables you to dependency inject into objects that are not created by the container. How does that work?
So normally, dependency injection mechanism is restricted to you declare a bean and then you declare its properties, and those properties are typically references to other beans or scalars. That's roughly the dependency injection mechanism. Now, you may have a situation where you have objects such as account and customer. Now, you are not going to have Spring Beans for those objects.
Because each one is unique, so you can't configure them.
Exactly. So essentially, for dependency injection to work, you need to have container in charge of creation. Whereas with account and customer kind of object, domain objects in general, you are probably creating through some ORM framework, and that's creating those objects. So what we have done is in Spring is we created a set of aspects, and those are reusable aspects. You can use them without writing an aspect. So all you do is you mark your objects, your classes with @configurable annotation. There are other mechanisms too, but a more popular way is to just mark your classes with @configurable. And Aspectj weaves into these classes to say whenever object is constructed or deserialized, it will inject it with dependencies.
So under the hood, it's got some kind of point cuts that allow it to trap the events where the injection needs to occur. So where this is leading is to a point you made in your book. You suggest that the decomposition that is very popular in these type of applications into services and entities is really a technical artifact that doesn't necessarily make sense now that you have these other these capabilities. What did you mean by that?
That's a very good question. And I try to make this point in various ways. So what is typical web application look like? You have a web layer, then that web layer calls service layer is called repository layer calls database like ORM or JDBC. And that's nice and neat, it seems reasonable architecture. The problem kind of is, you kind of look back and saying, what is this service layer exactly doing? In most cases, you will find that service layer is a mere forwarding mechanism to repository or to domain objects. And then you look at domain objects and you see like, well, they're really anemic. As in, they just have getters and setters and really have no interesting behavior. So now you start to look at it and saying, well, then do I really need services?
Because we can configure the service for dependency injection, but we can't configure the entity.
That's part of the reason. And the other reason is, once you have services as beans, you can apply Spring AOP, because then you can create proxies for it. So Spring is in charge of creating services, so it can then create a proxy to it.
So we're going to come back to the proxies, but go ahead on this question and then we'll talk about proxies next.
So you should not create anything in software that doesn't have a real need. That's the basic principle I'm going to go with. So you have to look back and saying, do I really need services? If I give a mechanism that says you can apply transaction wherever else you want, it doesn't need to be Spring Bean, and you can inject dependency injection wherever you want. It doesn't need to be Spring Bean. If I give you that, would you really want service layer? The answer it turns out to be is actually no. You don't need service layer for just this simple purpose. I will expand on, there are places where you need service layer. I will come back to that in a minute.
So I think your point so far is the service and entity combined constitute a single abstraction from a domain modeling standpoint, and we just split them up into two halves because of really a technical reasons.
Exactly. So I want to look at like saying, is it a technical reason or there is a real domain or application level reason for it? So what you can do is, since Aspectj provides a mechanism that can extend transaction management, security, etc. to any object, and it can extend mechanism of configurability as in dependency injection to any object, what else you need? In fact, Spring has an open source project called Spring Roo that takes these ideas and actually creates a product out of it.
So I'm going to come back to Spring Roo. So let's come back to that.
So you will see that once you start to use Aspectj in real good, reasonable sense, reason for using service layer from this simplistic perspective at least goes away. Now I will go back to service layer. You need service layers in many cases. And those service layer is typically as a facade to your application. So let's say you want to expose some functionality of your application to, let's say, outside payment system, right? So essentially integration layer. That service layer comes because it makes sense from your application point of view to serve other parts of your big system. In that case, I would say go ahead, use service. So essentially, don't use service because somehow technical reasons are driving it. Use service layer if it is natural. You find a natural reason to have a service.
It's interesting to realize how much of design patterns come about by convention, and then you forget why the convention applied in the first place until some new technology comes along and forces you to rethink how you decompose
Yeah, and that's
things.
actually wonderful. I mean, I think in Java world, we are at a crossroads where some of the assumptions that we made, like we must do certain ways, is being shaken. Not just Aspectj, but other languages too. And that's really an interesting position.
There's a perception among programmers that aspect-oriented programming is something to help you with these technical aspects that cross-cut your entire code base. But I'm wondering, should we also be thinking about our domain design and our domain model in terms of hierarchy, which is object orientation, and then cross-cutting domain concerns, which is aspect orientation? And should aspect-oriented design become one of the tools in our design toolkit?
Absolutely. I mean, the way I look at classes is classes often serve different clients. And by client, I mean different other classes. And each of those clients typically tend to have different perspective. So for example, if you have a domain class, there are some parts that are really meant for consumption of JPA, some ORM framework. Some parts are there meant for debugging, toString and other methods. So if you use aspect-oriented programming, you can segregate that. So you can say, here is a domain, core domain logic. Maybe then there are some additional domain logic that come from only some perspective. So for example, in ordering system, should it care about inventory management? Maybe, maybe not. Let your business decide that. But if it does, should you make order take care of inventory management right inside its code? Probably not. How about segregating into a part, and that part can sort of, for example, take care of those inventory management? Or an interesting example is human interfaces. So Martin Fowler blogged about this at a few years back. So the idea is, what is the right interface to a class? One class of thinking is minimalist. So offer the minimal interface that anybody can build on the top of that interface. But other one says, well, if I use minimalist interface, then that means I have to write a lot of code myself. Why doesn't it offer me a typical interface that I can just use it in a simplistic fashion? So you can use Aspectj to introduce that minimal interface. And then you can kind of bridge gap between these two groups of thinking. So by core, the object offers the minimal interface and Aspect introduce the humanization API. So there are several ways you can look at this class and saying class doesn't need to be written in one place. So I guess maybe the core message there is a class doesn't need to be written in one place. It can be segregated into a variety of ways. And those can compose a final view of the class. This one is actually a very deep question. It's very difficult to address it,
So you mentioned this proxy-based aspects. Tell us what that is.
So you want to, let's say, apply aspect to an object. There are two mechanisms. One, modify the class file, as in bytecode as seen by the VM, and put additional code in that bytecode. That's one mechanism. Other mechanism is take the class object as it is and wrap it in some other object. And that object is proxy. So essentially you make sure that the proxy gives the same API to the outside world. So if it is account service, if your bean is implementing account service, let proxy also implement account service. To the outside world, it looks like an account service. However, when somebody makes a call on proxy, before you forward it to the underlying object, you can do some additional stuff and on the way out as well. And that's how you can implement your before advice, after advice.
The proxy wrapper is Spring's way of accomplishing the weaving in Spring AOP.
Exactly,
correct?
without using a special compiler or a weaver.
You've mentioned the Spring Roo project, which relies heavily on Aspectj. What is Spring Roo?
Spring Roo is a project that brings productivity that you see in Rails and Grails environment in a statically typed language, which is Java. So what Spring does is it combines Java with Aspectj with some code generation and gives you a very good productivity. So you can create a good web application in a matter of few minutes.
And how does it use Aspectj to make that possible?
Several ways. So typical problem when you say code generation is usually you tend to shy away from such tools, because when you use code generation, you will typically see the code get generated and marked with a block, do not edit it. And if you edit it, bad things will happen. And that tends to really kind of, turn you off. So what Spring does is it generates code in aspects that are associated with the main class. So in the main class, you simply write your domain logic. So you write your fields, you write your methods, business logic. You do what you would do in a typical plain old Java object. And Roo will take that class and generate associated aspects. And those aspects introduce methods to your domain objects. So it will introduce, let's say, a finder method or introduce a toString method. It will introduce all those methods. It will attach annotations at the appropriate places. And you don't have to worry about it. You don't modify the aspects. If you want to override the behavior in an aspect, you simply write that method in the main class, and then the aspect code won't disturb that code. So essentially, the code generated is kept away from your main classes. That's one way. The second is it uses transaction management woven using Aspectj. So it uses Spring Aspectj, the aspects that are written as a part of Spring framework to do that. It also uses the dependency injection into your domain objects. So essentially with Roo, what Roo allows you to do is it allows you to focus on what is really important. That is your domain class. So you worry about your class and everything else kind of comes through that. And that's how, in my opinion, how software should be written. You should focus on what is really important.
When you read the typical class that's been hand-coded, you have this tangling of all the domain concerns and all the technical concerns in the class, and this really allows you to untangle and have each thing be understood on its own.
Absolutely. And when we talked about earlier service layer and how does it, or repository layer and unnecessary layering, Roo allows you to really get rid of all those things. So Roo class, it can introduce repository like behavior. Service itself, you just introduce behavior in the class itself. So you have a very rich domain model. And let Roo handle everything else. So it's really kind of brings productivity, and it's kind of very interesting when you watch Roo presentation that from scratch you can create a full-fledged application that you can test it along with the test it writes tests as well. Everything done in matter of, let's say, half an hour.
Spring is very popular in developing enterprise applications. What are some of the more common enterprise cross-cutting concerns? You've mentioned transactions, certainly. That's a big one.
Yeah, so we talked about earlier policy enforcement and tracing. The other one starts at like auditing. So if you got some auditing requirements, saying some sort of compliance, HIPAA compliance maybe, there you want to monitor your application at various points. So essentially it's an extension of tracing, but it into from a very different perspective.
It's more from a business perspective.
From a business perspective. So you have requirements. So what you can do is now you can annotate whatever the classes, whatever methods.
So we need to keep track of whoever's done any transactions on the account, for example.
Right. So that, in case something really goes wrong, it may save your company. So from that point of view, those are the aspects. You start at the like a simple aspect, which is extension of tracing, but more you must put them in production. They are not something that you put in one day and take it out like tracing aspect.
They're part of they're part of the business requirements of your application.
Exactly. And then you have concurrency control. Those are also enterprise applications. So now with all of the Ajax and other things going on, you can have your objects in session, for example, being bombarded with queries from multiple threads. And you have to make sure that they behave the way you want it. So essentially, if you are in a concurrent environment, you want to make sure that your concurrency is taken care of, or whatever policies that you may have set up are appropriately followed. Then, of course, the transaction management. It's the most and the first aspect that you are likely to use if you are, let's say, creating a Spring-based application.
And Spring provides you with some pre-built transaction management aspects, correct?
Yes, and that's an interesting one, is where you may actually be using AOP and not realize it, because the way it is, it's really encapsulated in a very nice way, where it really all boils down to writing a couple of lines of code in your configuration file.
I guess you could say that AOP is a generalization of a capability that the J2EE servers had of declarative transaction management.
That's a very good to put it. I mean, essentially, in fact, I just, when I was working on second edition of book and when I was about to write my preface, I went back on my first edition and said, what did I say then back then? And I kind of was pleasantly surprised. I mean, I probably was overboard and I made a prediction that didn't come out as quickly as I thought. But I essentially said, like, what do you need a J2E server for? You need, first of all, a web server kind of situation, kind of manager. And then you need somebody to take care of your security and transaction management. Rather than taking this whole thing solution as a one thing, monolithic solution, can you not pick and choose? Can you not say, oh, here is the security I want, here is the transaction management I want? Because then I don't have to surrender to how the way server does, a J2E server does. I can say, you know what, I want a field level security. So I'm going to take these additional aspects. So you can essentially create your own.
Modularity gives you pluggability.
Absolutely.
So within the Spring project, you have Aspectj, and as you explained, you can use Aspectj to create aspects. You can use Spring AOP. What do you think? How should we approach trying to use these? Should we use one and pick the one we like? Should people use the best tool for the job and mix and match them together? Or what's the best use of one versus the other?
That's actually a very interesting question, especially if you're just starting with AOP and you kind of want to say, I mean, one of the things is that happened with Aspectj, let's say over the last 4 years or so, is we now have a lot more choices. Back in the days, it was very simple. There was one kind of viewing, but there were two kinds of viewing. And that's about it. There was one kind of syntax and that's about it. Now you kind of have lots of choices. And choices, while good, also create confusion, right? What do I do? I mean, do I use this kind of syntax or other kind of syntax? Do I use one kind of viewing or other? The way I kind of approach is if you are starting with, let's say you are already a Spring application, I would say start with Spring AOP. Write aspects using that annotation-based syntax called Aspectj syntax. Use that syntax to write your aspects, weave them using Spring's proxy-based AOP, and start understanding what AOP is all about. Start understanding how to write a point cut. Start understanding how to write an advice. At some point, you will kind of exhaust the possibilities because Spring AOP applies there are a couple of limitations there. It applies only to Spring Beans and it can only intercept methods. So if you want to, let's say I want to advise constructor or I want to apply an exception block, you can't do that with Spring AOP. So when you reach that point, you go to Aspectj because now you already learned the concepts. You already know how to write an aspect. Now you're only learning how to weave them using a different mechanism. And once you understand that, you will also exhaust at some point, although probably it will take you very, very far, where you might want to use even more complex and powerful techniques, and those techniques are also available only with traditional syntax. So at that point you can switch over to that traditional syntax only for some aspects. So therefore it's more mix and match.
So in my experience, I started out using these two tools independently. I arrived at the view that the Spring AOP aspects are larger grained and more suited for the business concerns, whereas with Aspectj you can get as fine-grained as you want, and you may be dealing with things like threading and concurrency that aren't really business concerns, they're more technical concerns. Is that a common view?
Yeah, that's a good way to get started. I mean, essentially the way I kind of say is get started with Spring AOP and let experience be your best guide. So at some point you will automatically come to your own conclusion what is appropriate.
So I'd like to pick your brain a little bit about some issues around AOP and why it maybe isn't more widely used than it is. In the 6 years since you came out with the first edition of your book, there are still relatively few titles on AOP compared to the object-oriented revolution, which produced a massive explosion of books and still has hundreds of titles. Is AOP mainstream, or is it still a little bit out there, considered more experimental at this point?
I would definitely say it's not experimental anymore, and we can talk about some of the products that use AOP in a very core way. But coming back to your question of number of books being published, there are actually quite a few books that got published right around my book got published. So until 2005 or 2006, lots of books that got published, and there was a kind of a void in between. And then I have my book, and hopefully it gets followed with other books. One of the thing is object-oriented programming is, depending on who you talk to and depending on what you consider start of it, it's about 30 years old. So it does take actually a significant duration until people start to get comfortable with it. And I know, I use object-oriented when it was a sort of already mainstream, But I have seen, like, especially I worked in real time with real time systems, and object oriented was pretty frowned upon in those kind of systems. So it takes quite a bit of time to get adapted. So I would say aspect oriented programming is a sort of a midpoint. It is an inflection point at which it better start to make inroads into in a core way. Unfortunately, in my opinion, it is already making that way, and it's going to take a while before it really starts to become like something that you sort of do it without thinking too much about it.
So you say in your book that we passed the peak of overhype and we're in the productive plateau of the Gartner hype cycle. Would you care to elaborate on that?
Yeah. So the Gartner hype cycle basically follows through several phases. Essentially it starts, there's a technology trigger. So product gets announced, and then sort of, if it is something good or something you can think as a good, then it can get hyped. So everybody starts to go on this bandwagon saying, all right, aspect-oriented programming, wonderful, I can use it for anything. And that happens for every technology. And in fact, we can already see like certain things are going through that phases right now. So it goes to that very high expectation. Everybody thinks every problem can be solved with that technology. And it can't, because it wasn't really meant to even. So then it suddenly people start to say, oh, well, I can't really do that with that technology. And it goes down and into like a trough of disillusionment. So you're like disillusioned saying, it really wasn't what I thought it would be. And at that time, however, those who really understood the technology reasonably well, or those who are looking at it already from a very reasonable point of view, starts to use it as a competitive advantage. They say like, okay, this technology can do that, but not other things. So they start to use technology in its sweet spot. And then it goes on to what I call like slope of enlightenment. So slope of enlightenment is like you really understand the technology's strengths and weaknesses and starts to use with its strengths but not for its weaknesses. And then it goes to plateau productivity, where you don't really think much of it. Like, for example, Java, right? You don't go and brag about using Java anymore. There was a time 10 years back when you would say, oh, you are a Java programmer, wonderful. You don't say that anymore. Now you have to say any of these cool new languages, and then you can still brag about them. So I believe that its Aspectj is somewhere on the slope of enlightenment, and it will probably reach plateau productivity in next few years. And the reason I see it, you will see that Aspectj pops in sort of unexpected places. So you will see that there comes a Spring Root product. All of a sudden it uses it. It doesn't make a big fuss out of it. It simply says, hey, look, here's a product that gives you productivity. By the way, it uses Aspectj. Or Spring Insight. It says, here is a way to get insight into your application. By the way, it uses Aspectj.
What would you say to people who think that AOP is a compensation for Java being too static and not offering metaprogramming features? Can everything that you're calling AOP be done with metaprogramming?
Yes and no, right? So can metaprogramming modify the classes to add new fields? Yes, it can. Can metaprogramming modify methods to add extra behavior? Absolutely, it can. The question is, there is a possibility and there is that the way to do it, right? So programming language are never about possibility, right? I mean, I can write enterprise application in assembly code. It will drive me insane, but I can. So possibility is never an issue. It's the question of doing it the right way. Metaprogramming, in my opinion, is a very powerful tool. And in some cases, it's really critical, in fact, that you use metaprogramming. And later on, hopefully will talk about Spring Root, and I can talk about in that context, metaprogramming, how it pops up there. But going back to the question is it, if I have metaprogramming, do I still need AOP? I would say yes. AOP brings actually discipline to metaprogramming, because metaprogramming is very powerful, but you sometimes don't want too much power, right? So in fact, if you think about it, even object-oriented programming is a disciplined approach that says, okay, here is a procedural programming, and you can really do anything you want. But encapsulation is really cutting the power, right? It's really, think about it, right? Why do you need a private field? If you make a public, it's powerful, but you want discipline. So it's really a balance of power versus discipline.
So you could think of Aspectj as a DSL for doing a limited subset of metaprogramming functions.
Absolutely. I just want to make it clear that I do not want to say that metaprogramming substitutes Aspectj or AOP. I also don't want to say that AOP substitutes metaprogramming. They both have their place in a programming system, and you should use them correctly. You are going to get quite a bit of leverage out of it.
Let's talk a bit about the Aspectj project. It is an open source project. It's been adopted into the Eclipse family. Tell us the history of the Aspectj project.
So Aspectj started at Xerox PARC in about 1996. And it was started, the person who led this project is Gregor Gonzalez. And interestingly, to connect back to the earlier question, he wrote a very interesting and very well-referred book on metaprogramming. So he knows what metaprogramming is and he knows what could be powerful. And that's why he got that perspective in saying, what would it take to bring metaprogramming to statically typed language? And that's basically how the Aspectj started. Anyway, so Aspectj started, it was open source project back then, under a different license. And at some point it got transferred to eclipse.org under EPL license, Eclipse license, which is very liberal. And at that time, most of the people working for Aspectj were from IBM. And later on, Adrian Collier, who is the Aspectj lead, left IBM and joined Spring Source. Just about that time, I also joined Spring Source. I was independent consultant back then. And a bit later, Andy Clement, who was with IBM, also joined Spring Source. Recently, Andy Eisenberg, who is a doctoral just finished his PhD and working with AOP for a very long time, also joined Spring Source and working on Aspectj. So a lot of development is going on in Aspectj, and Spring Source is right now supporter of Aspectj. So essentially, pretty much the sponsor of Aspectj project.
So most of the main committers to Aspectj are Spring Source employees. You said there's quite a lot of development going on. Can you tell us what's going to be in some of the subsequent releases?
Right. So I will take a perspective of like what happened over the last couple of years. One of the things that happened is the core got stabilized. It took a long time for Aspectj to really stabilize. And this is not really only with Aspectj, a lot of other projects also got bit sort of sidetracked, if you will, in the end, at the end for good reasons, if you like generics, that is. But Aspectj also got pretty sidetracked with, making sure that annotations are supported well, making sure that all the new viewing models are supported well, generics are supported well, and so on. And as a result, some of the issues such as performance, memory consumption got sidetracked. Over last 2 years, there has been tremendous amount of energy that has been put into these issues. So Aspectj compile time performance has improved significantly. Aspectj's memory usage has gone down significantly. The bugs are far fewer now. I mean, you really have to find a very complex case to really find a bug. So there was a time when there were bugs, but nobody was there to look at it because they were busy with other things, like making sure generics are supported. Now, if you give a bug, which with anything related to core, the bugs get fixed like in a few days matter.
So would you say the project is well funded and well staffed now?
Absolutely. And there are more people that might be joining project as well.
Is there an active community around it?
Yeah. So Aspectj has two communities, I would say. One is the core Aspectj user community, and then there's a Spring AOP community. Both user mailing lists are pretty active, both forums. In case of Spring AOP, there's a forum, and Aspectj, there is a mailing list. They're pretty active, so if you ask a good question, or a question in general, you're likely to get a very helpful answer. That's another thing you will see is if you join the Aspectj community, you will be welcomed, you will be helped.
Where can people go if they want to learn more about the project and the community?
Yeah, so go to eclipse.org/Aspectj and go to eclipse.org/AJTT for the tools project. And there are mailing lists. You can join those. For Spring AOP, go to springframework.org and then you will get into forum, and there is a Spring AOP forum. So those are the places to hang around.
You've come out this fall with the second edition of your book. What is new in the second edition from the first edition?
So the first edition was really about what is AOP and what can you do with it. It did not, however, have a very solid context in terms of what application frameworks you are going to use. So at that time, Spring was very new and wasn't a mainstream framework. Now Spring is de facto standard in case of Java lightweight frameworks. So what I did is with the second edition is to put Aspectj in Spring context. So you create your application based on Spring and use Aspectj to create the cross-cutting concerns around it. So what I did is, and more things have changed. One is the whole Java changed a lot in last 6 years. There I could use JDBC and that was a reasonable solution back then. Now you have to use ORM framework. Earlier I could just use Ant and just a batch scripts and that was good enough. Now I have to use Ant and Maven and other things. So what I've done is I kind of modernized every single thing. So my first edition, the goal was to make it relevant to every Java programmer. The second edition wanted to keep this goal. So Java changed and so did book. I also basically modified how aspects are written because my knowledge of how aspects are supposed to be used changed. By working with customers and various projects, I have a much better understanding of how you should be using Aspectj. So I kind of basically put all this knowledge together, how Java has changed, what my perspective has changed, and put them into this book.
Who's the intended audience for the book?
Mainly, I would say mid to advanced Java programmer. So if you're really comfortable with Java, then you should look at Aspectj. You also, if you're a Spring user, then you're definitely an audience here. Pretty much every application, every example is based on Spring.
Where can people find the book?
Go to manning.com/Laddad2, or just probably you can search Aspectj in action on Google.
If people would like to follow your work, do you have a blog or Twitter?
Yeah, I have a blog. I blog a couple of places. It's not very active, but I intend to have a series of blogs that I should be coming up soon. One is on Spring Frameworks team blog. Another one is aspectivity.com, or you can go to ramnivas.com/blog. Let me redo it.
If people want to follow your work, do you write regularly anywhere?
Yeah, you can follow me. First thing is on Twitter. So you can just follow me on twitter.com/Ramnivas, RAMNIVAS. And you can follow my Spring Source team blog, where I blog as well. You can follow also on ramnivas.com/blog, where I put some not necessarily related to Spring, some more specific issues that blog about those at my personal blog.
And if people would like to reach you, if they have any questions about your book or comments, how can they reach you?
Few places you can ask me on. If it is related to Aspectj, just ask on Aspectj user mailing list. I hang out there, so I might answer there. There is a books forum on Manning's website. So if you go to manning.com and look at my books link, there is a forum. You can ask book question related to the book itself. If you want to ask about Spring AOP, you can ask on Spring Forum. I follow that as well. And you can always find my email address and ask me a question. If that's
We'll put all that information in the show notes. Ramnivas Laddad, thank you for telling the listeners at Software Engineering Radio about your new book and about Aspectj.
Thank you, Robert. This was really nice talking to you.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.